Give the next 8 problems a try on your own to see whether you can recognize which method to use would be the best method, and whenever you're ready we can continue the video over here. And to start, I just listed out the methods I think will be the best for all 8 parts first. And there are expressions, as we said, if there are only 2 terms, these are going to be special forms of some sort. The first one, I recognize that it's going to be a difference of squares because 25 is a square number, 36 is a square number, and it's a difference of 2 terms. And then we also have this part F, which has 4 terms. That's a typical factor by grouping. There's no other method for us. And for part H, this again is 2 terms, and this doesn't work as a perfect square, or sorry, difference of squares, because 15x is not a perfect square. So we're going to resort back to GCF. Also, you can recognize there's no constant term here. When that happens, we again want to use GCF. And meanwhile, if you look back to part B, this is, I said, just going to be a leading coefficient equal to 1, regular factoring. And part C is going to be perfect square trinomial because I recognize 4 is a perfect square, so 4x squared is a perfect square, so is 9 being a perfect square. Part D, you can possibly think it might be an AC method, but if you think about the product of A and C being positive 15, and we need the sum of these 2 factors to be 1, this doesn't really work because we can't find 2 numbers, 2 integers that work that way. So I know it's going to be a quadratic formula. So it is a little bit longer process to recognize that one. And part E, we can, again, just like part D, you can think about AC method first. And if it doesn't register to you right away whether AC method would work, you can always tentatively start with AC method and see whether you can find such factor pairs. And lastly, for part G, it's a trinomial. We recognize there's greatest common factor we can take out. So if you take out a factor of 4, the leading coefficient becomes 1, and we can go from there. So these are the methods I listed out. I thought it might be helpful for you to check that first, and if you want to take some more time before looking at all the solutions, go ahead and do that, and if you want to change anything that you have already done, this will be the time to go through before looking at the solutions. And now I'm going to go ahead and just go in order to tackle all the problems. The first problem I know is difference of squares, and I can recognize A is equal to the square root of 25x squared. Square root of 25 is 5, square root of x squared is x, and B is going to be square root of 36, which is 6. So altogether, that means f of x would equal to 5x plus 6, 5x minus 6. That's how the difference of squares work. And if I want to set this to be equal to 0, that means 5x plus 6 equals 0, or 5x minus 6 equals 0. And therefore, x equals negative 6 over 5, or x equals positive 6 over 5. Whenever you have difference of squares, you're always going to get that result as the x-intercepts over here. So we can say negative 6 over 5 comma 0 or 6 over 5 comma 0 are the x-intercepts. They are exact opposites of each other because of how different squares work out. It'll always happen. Now for part B, leading coefficient is equal to 1. That means we want to find 2 numbers that would have a product equal to C, which is negative 15, and the sum equal to B, which is negative 2. And we will see the 2 numbers being directly used in the form that would be two factors each being a binomial and starting with x, and we would just plug the 2 numbers in. We can find out the 2 numbers we get will be negative 5 and 3. So we just put negative 5 and positive 3 like that. And therefore, to find the x-intercepts, we set each factor to be 0, and you will find it's exactly the opposite of the 2 numbers we got. So we found negative 5, so one of the x-coordinate is x equals positive 5. The other one would be x equals negative 3. So x-intercepts give us 5, 0, and negative 3, 0 as a result. Moving on to part C, we have this perfect square trinomial. I said I recognize it because first and last term both are perfect square terms over here, and that means I can write a equal to 2x and b equal to 3. And once we have this form, we want to check whether 2ab equals the middle term, which is 12x, 2 times a, which would be 2x, times b, which would be 3, and check whether that's 12x. Indeed, it is 12x on both sides. So we can write h of x as a minus b squared. It's minus because the linear term has a minus over here. And once we do so, we would get 2x minus 3 squared. Now go ahead and set that to be equal to 0, meaning x will be equal to 3/2. So only one x-intercept when we have a perfect square trinomial, which is also the vertex. This is something to keep in mind whenever you have to graph as well. Now moving on to part D, we already said AC method won't work because A times C need to be 15, and 15 only has factor pairs of 15 and 1 or 3 and 5. Neither of them add up to positive 1 as a sum. So using quadratic formula, x equals negative b plus minus square root of b squared minus 4ac all over 2a. Negative b is negative 1 plus minus square root of b squared, which is 1 squared, minus 4 times a, negative 3, times c, negative 5 over here. And as I'm writing this, I hope you're recognizing something. Once we do so, we want to again look back to the radical part under the square root. I hope you recognized as I'm writing this out, or as you were writing this out yourself, you can see that we would have 1 minus 4 times 3 times 5, because we have 3 minus signs, so this will be subtracting some number that's much larger than 1. We can calculate it's equal to 60. So in this case, whatever is under the radical is negative, so we can say there's no real solution or no real answers for this equations to our j of x equal to 0. And when we say no real solution, that means there's no real number that would work out. And therefore, when this happens, we say there is no x-intercept. And this happens before, so this is a quick recap for this possibility. And moving on to part E, if we look at k of x, we want to use the AC method. For the product, we need a times c, which is 6 times 4, equal to 24. For the sum, we need it equal to the linear coefficient, which is negative 11. If you have gone through all your options, you will find the two numbers we found are negative 8 and negative 3. Again, if product is positive, sum is negative, that means both numbers need to be negative. And once we have this, we can rewrite k of x to be 6x squared. Now we rewrite the middle term. Negative 11 can be written as negative 8 and negative 3. And then we copy the last term again. Now again, putting the first two together, last two together, put a plus sign here. And the first parentheses, if we take out the GCF, we will have 2 and x both being part of the common factors. That leaves us with 3x minus 4. Second parentheses, we can factor out a negative sign, and that's about it. Plus a negative 1 makes it negative, and that means we change all the signs inside the parentheses. That becomes 3x minus 4. And therefore, we get 3x minus 4 in common, and then from the first term, we have a factor of 2x. Second group, we are left with a factor of 1. Always recognize, even though we don't write it, it's technically 1 times 3x minus 4. So now to find the x-intercepts, we set each factor to be 0. and therefore x equals 4/3 or x equals 1/2. And the x-intercepts we get are 4/3, 0, and 1/2, 0. Moving on to part F, feel free to again pause whenever you need to take more time to digest all the information, but I'm going to keep going. You can always pause the video. For this one, for part F, it's factor by grouping, so I'm going to automatically just start grouping first and connect it by plus. Now for this one, in the first group, we have a common factor of 3 and x. Take that out, leaves me with 4x minus 3. And from the second parentheses, again, I can factor out a minus sign. So once I do this, plus minus becomes minus. Leaves me with 4x minus 3 again. And same thing as before, even though there's nothing outside 4x minus 3 in the second group, it's technically 1 times that. So we should have 4x minus 3 times 3x minus 1. And to find the x-intercepts, 4x minus 3 equals 0, or 3x minus 1 equals 0. So x equals 3/4, or x equals 1/3. So the x-intercepts are 3/4, 0, or 1/3, 0. For part G, we said there's a GCF we can factor out first, and so is H. So GCF is definitely a helpful trick to always keep in mind, even though it's easy to overlook. GCF among the 3 terms would be just 4. Once we do so, we would have x squared plus 10x plus 21. And now in the parentheses, we just have a trinomial with leading coefficient equal to 1. Once we have this form, we can go ahead and think of the sum, and sum equals to 10, product equal to 21. If you go through all the factors, you should recognize the numbers being 3 and 7 that satisfy this condition. So I can really rewrite the m of x in this factored form to have x next to start, and the two numbers are both positive, so we would have positive 3 and positive 7. To find the x-intercepts, we set each factor to be 0. Again, 4 cannot be 0, so we more or less just leave it alone. We don't have to do anything with it. And we get 2 x-intercepts. -3, 0, and -7, 0. Lastly, for our part H, this is actually a shorter problem because we can recognize it's going to be just a GCF problem. Leading coefficient is negative, so I'm going to factor out the negative sign. And then 12 and 15 share a factor of 3, and they both have x in it, so the lowest degree of x is just x to the first degree. I'm going to factor that out. And now if I factor out -3x from -12x squared, that leaves me with 4x. Same thing for the second one. I should have a negative value now because I took out the negative sign. So I should be left with -5. And altogether, to find the x-intercepts, we have either, you can put -3x equals 0 altogether, or if you recognize it, you can just say x equals 0, because -3 as a factor cannot be 0. Or 4x minus 5 equal to 0. That gives us x equals 5/4. And therefore, the x-intercepts we get are 0, 0, and 5/4, 0 as a result. And that's how we work with a mixed bag of problems with different factoring methods, or even non-factoring methods like quadratic formula, and how we can use all the methods we have learned so far to find x-intercepts.